Welcome to Mrs. Bibb's Algebra 2 class, first 9 weeks, week 9. Please make sure to do your warm-up, then get out your page 43 that should be included in your folder. We'll do these notes on the application of trig ratios. Remember SOHCAHTOA. When we're looking for the answers to questions like these, we can use this as a reference. It says that we want to find which of the acute angles F is an acute angle and E is an acute angle. So those would be our answers to these questions, F or E. D, obviously, is a right angle. Let's look at this problem. We want to find which of these two angles, angle F or angle E, has a sine that is 12 over 13. We have to think about sine being the opposite side over the hypotenuse. We are looking for the opposite side that has a measure of 12. Obviously, our hypotenuse has a measure of 13. Looking at angle F, opposite angle F is a measure of 5. So that's not going to be the answer to number 1. Opposite of angle E is 12. And of course the hypotenuse is 13. The answer to number 1 is angle E. For question 2, the tangent of this angle is 5 over 12. Tangent is opposite over adjacent. That's what I'm looking for over here, is an opposite side of 5 and an adjacent side of 12. F has an opposite side of 5 and adjacent side of 12. The answer to number 2 is angle F. For these next problems that we're going to complete, you need a calculator. Before we use the calculator, though, I want to talk about what this is saying. This is saying there's an angle G, an acute angle G, that when you take the tangent of that angle, you get this decimal approximation. To use your calculator to find that angle, you're going to use the inverse operation. You're going to use the inverse tangent. Inverse tangent 0.43. Let me show you how you do that. This is a calculator that I highly recommend to purchase if you can. In my classroom, I have a classroom set of these. But when you take the ACT or the SAT on a weekend, this calculator here is about $13 or less at Walmart. And it does a lot of the things that you need for it to do, and it's affordable. To do the inverse tangent, the first thing you want to make sure is that your calculator is in degrees. You change it from degrees by pressing this button DRG. And if it was in radians, then to change it to radians, you arrow over to it and press enter. And now you can see my calculator is in radians. So to change it back, I press the DRG button. I go back to DEG, press enter, and now I'm in degrees. Notice you have sine, cosine, tangent. Please do not call them sin, cos, and tan. Notice in light blue, above the sine, cosine, and tangent is inverse sine, inverse cosine, inverse tangent. What that means is when you use inverse sine, you're trying to find the angle, not the ratio of the side. You know, a decimal approximation for the ratio of the sides. You're trying to find the angle. To type in inverse tangent 0.43, inverse tangent is here. So I'm going to press the second button. Notice it comes up here second. I'm going to press tangent and type in 0.43. Press equals. And that gives me 23.26. In my instructions, it asks me to round my angle to the nearest tenth. So to do that, I look at the 2 in this problem. The 6 tells me what to do to the 2. Since this number is higher than 5, then I will put 23.3. Angle G is 23.3 degrees. Let's test that. Let's check to make sure we're correct. I'll press clear. I'm going to type tangent of 23.3 degrees. What is that? 0.43. If you do not have a scientific calculator like the one that I have just used, then you could get your cell phone out. Here's mine. I have an iPhone. All you have to type in is first your decimal, 0.43. Then you press your second button and you press inverse tangent. And you'll notice we get the same decimal that we got before, 23.2677. The 6 tells me to round that up to a 3, so I got 23.3 degrees. You're welcome to use your phone or your parent's phone. I'm going to have to use inverse sine. Please show your work this way. To type it in, I will type second sine, that's inverse sine, 0.68. I always try to close the parentheses. Press equals. I get 42.84. Angle H is going to equal 42.8 degrees. To find angle K, I'm going to do inverse cosine of 0.94. Clear. Inverse cosine 0.94 is 19.94. The 4 tells me to leave the 9 alone, so 19.9 degrees. For number 6, it says solve the right triangle. What does that mean? That means that I need to find any missing sides or angles. First thing I want you to notice, this is angle C, capital C. Across from capital C is lowercase c. That's a missing side. I know from this triangle that lowercase b is 2. This represents side B. Side B is the side that's across from angle B. So 3 represents the measure of side A. I need to find side C. I don't know what angle B is, and I don't know what angle A is. These are the things that I need to find to solve the right triangle. Let's start with side C. This is a right triangle. To find a missing side of a right triangle, you use the Pythagorean theorem. I know the 2 legs. I need to find the hypotenuse. A squared plus b squared equals c squared. 9 plus 4 equals c squared. 13 equals c squared. C is the square root of 13. To find angle B, I need to use any of the 3 trig ratios. It does not matter. I think I'll use sine to start with. I know the sine of angle B is, remember sine is opposite over hypotenuse for sine. The sine of angle B is 2 over the square root of 13. Technically, if I wanted to write it properly, I would rationalize. the sine of angle B is 2 times the square root of 13 over 13. I need a decimal approximation for 2 times the square root of 13 over 13. Let's find that. 2 times the square root of 13. Let me show you how I got that. Of course, I typed the number 2. To get square root, I see the square root symbol here in blue. So I press second square root, 13, and I close the parentheses because I want to divide by 13. What you see typed here is what is written here. 2 times the square root of 13 over 13, 2 times the square root of 13 over 13. So I get 0.5547. I'm going to write sine B equals 0.5547. Now, to find angle B, I do inverse sine 0.5547. Inverse sine 0.5547. Angle B is 33.7 degrees. There are 3 other ways we can find angle A, and I'll show you all 3 ways. You could go through the same thing, and let's use tangent this time. Tangent of A. We know the tangent of A, we're going to use opposite over adjacent. Opposite A is 3, adjacent to A is 2. We know 3/2 is 1.5. To find angle A, I'm going to use the inverse tangent of 1.5. Let's type that in. Inverse tangent 1.5. 56.3. The 0 tells me to stay there. So 56.3. It is not necessary to do all 3 ways. You could have used the fact that the sum of the angles of a triangle is 180 degrees. You knew angle C was 90. You knew angle B was 33.7. You did not know angle A. 90 plus 33.7 is 123.7. And then to find angle A, you subtract, and I do believe if we type that in the calculator, 180 minus 123.7, you're going to get 56.3 degrees. And we did. The other way that you could have done this is knowing that if angle C is a right angle, then the 2 acute angles have to add up to 90 degrees. I did not at the time know angle A, but I do know that angle B is 33.7. If I subtract 33.7, I won't prove it because I'm sure you know that I would still get 56.3 degrees. And I have solved that right triangle.